Hello, everybody. Welcome to today's webinar, Excessive Oil Consumption Diagnosis on Modern Commercial Engines. I am Amanda Harmoning. I'm an admin assistant here at AERA, and I will be helping moderate today's event with my colleague, Rob Monroe.
Hey, everyone. Yeah, Rob Monroe here. I want to thank you for joining us today. I look after membership and technical development at AERA, and like Amanda mentioned, we've got a really good webinar for you today. We're going to have some really good presentation on oil consumption diagnosis for modern commercial engines. Another thing, we've got the Engine Professional podcast, just another way for us to get technical information over to you. Steve and Chuck, they're both techs here at AERA, and they do the podcast. And we just finished up number 14, where Steve and Chuck talk about the importance of inspecting and checking your parts before you start to assemble that engine. So if you want to listen to our podcast, just go over to our website, aera.org. You'll see the podcast tab there, and you'll be able to just click on that, and that'll take you right in to listen to the podcast. You might be looking for some engine bags or some tubing here in the next little bit. We've got a sale on right now. We've got 20% off our bags and tubing, and that goes through from now till the end of March. So all you need to do is go onto our website, just go to aera.org. We have a store tab. You'll be able to click that, and you'll see all of our store type items there where you can purchase bags, manuals, there's books, there's wearables, that kind of stuff. So just use that New Year 22 when you go to checkout, and you can grab those bags and get yourself going. Another thing we got is our Engine Professional magazine. The first quarter edition, which is the January to March edition, is now out, and it is hitting mailboxes now. If you'd like to receive this magazine and you're listening today and you're not getting it, just let us know in that questions box. Just put your contact information in there, and Amanda's going to ask you for your address and how we can get that mailed out to you. And we'll get you on our list, and you'll receive that magazine 4 times a year. And if you don't want to do it that way, of course, you can always read the magazine on our website, so you can read the digital version, and that's at engineprofessional.com. So do check that out. We're celebrating our 100th anniversary this year. So for 2022, AERA is 100 years old. We're pretty excited. We've got a lot of things coming for that. Look out for, especially articles in the magazine. We've covered a lot of our history, covered sort of where we were and where we're going and that kind of stuff, as well as our technical information. So Engine Professional is there for you to check out. All right, well, what I'm going to do is going to turn things over to Reiner. And Reiner Holwein, he looks after technical service and training for TRW Products at MS Motor Services International. Reiner, how are things going today for you?
Okay, from my side, my name is Reiner Holwein. I will introduce first myself. My name is Reiner Holwein. I'm technical trainer by Motor Service International. This is from Kolbenschmidt, the aftermarket, and I responsibility for the training for different countries. It's starting by America, Russia, Poland, Scandinavia area, UK, Spain, Italy, France, Germany, and I'm now 15 years in the company for make the different trainings by the customers or also by the reconditioner. I work very close to the reconditioner when they have some questions about to preparing, to repairing, and have questions about of failures maybe, and this is my big business. Today I will bring you some topics in this webinar. One is this special oil consumption. This is a big discussion every time when we maybe overhaul an engine and they have some problems. First, we have a general information about oil consumption, then the calculation of the oil consumption, and then the influence, what can influence the oil consumption, and then also some possible failures by the installation. When we first give an overview of the oil in the engine, the task of the oil in the engine have different, I will say, main points. One of the point is they make the lubrication and reducing the friction between the piston rings and the surface of the piston bore, of the engine bore, sorry. This is the lubrication. Also, the oil have also the big point to cool down the piston. And when we speak from a piston with a cooling channel inside, that means when we spray the oil in the oil gallery in the piston, aluminium piston or steel piston, to cool down the piston. And this is also in the newer generation of engines, most of them with a higher horsepower, they have a cooling channel in the piston. This is why we need the oil to cool down the piston. They are not overheated. And the last point, it's the sealing area. That means to seal between the piston rings and the surface of the engine bore, from the surface of the engine bore, between the piston rings and the bore, we have oil between, and this makes the final sealing between the combustion area down to the oil pan. I will highlight. I must go to other color here. That means exactly in this area. I think you can see it when I write it, drawing inside. And this is also very important. And one of the biggest point that you understand, hopefully after the webinar, the sealing effect from the oil between the cylinder bore and the piston rings. Now the next point. This is also important that you understand, because when we later discuss closer to the situation of the oil consumption, the tribology of the system of the piston and the bore and the liner and the oil. You see on the right side the piston ring and the cylinder bore. And the yellow, it's the oil film. When we speak between the piston ring and between the surface of the cylinder bore, the oil film, we have maybe around 0.3, 0.4 micromillimeter. This is the thickness of the oil film. And we need this oil film to make the final sealing. When we have too much oil there, then the sealing, it's not properly good. When we have less oil film, then we have contact with the piston ring and the piston bore, or the surface of them, and then we have wear on the piston bore on the surface of them, and also on the piston ring itself. The piston ring, it's swimming, it's sliding on this very thin oil film, and it's running up and down. This is also one of the biggest point, all they understand it. Here you see on this slide a surface from a cast iron cylinder bore. And you see this is an engine block, is a Deutsch engine, is a 7.8 liter TTDC 7.8. This is from a tractor, and this is also my favorite, because I study agriculture. You see the surface on this gray cast cylinder bore, and you see the accumulated oil. You see the scratching marks on the surface from the honing process. That means we need on the surface also a definition of rough area that the oil can be clamped and hold on the surface of the cylinder bore on the surface. When we are missing these scratching marks from the honing process, then the oil will be dropped definitely down, and we cannot build up this oil film. Together with the surface from the cylinder bore, and with the rough, how rough is the surface, and also together with the oil, with the viscosity, and how it's the pressure from the piston ring, this is the effect, how good is the sealing effect. That no compression from the compression area can drop down to the oil pan. Any questions up to here, then please write it in the chat what also Rob said it to us. I will give you some small time that you can write it down, and then Rob will take it all together for the end of the presentation. When we speak from oil consumption, in the most situation, the customer, your customer, when you are working in the workshop and overhaul engines, they came maybe and say, now I overhaul this engine in your company and now I have oil consumption. The oil consumption is too high. This is maybe in some situation, yes, can be, but we are needed more information how they calculate it. First, when we speak from oil consumption, I will not speak here in this webinar about oil consumption when oil drops down to the floor. We will only speak with oil consumption when they came to the combustion area and burned in the combustion area. And then we have normally on the exhaust pipe, we have a blue smoke. When a customer is come and say, I have oil consumption, how do we evaluate it, the oil consumption? They can come and can say, I need X liter to the next oil change, X liter per day, or X% to the fuel consumption, or X liter per 100 or 1000 kilometer. What do you think is the right evaluated? How it's the right calculated, and what it's give you exactly, is this engine need oil consumption or is it right or wrong? X liter to the next oil change give me not exactly a signal how high is the oil consumption. Also, X liter per day, I don't know how far, how strong is the engine using in this day. The best way what you can do it, X% to the fuel consumption. This is the right calculated, the right amount that you can say yes, and this basic I can talk about of oil consumption. Some of them also X liter per 100 or 1000 kilometer. But the original, the best way you can do it is oil consumption is measured and evaluated in relation to the fuel consumption. That means every time you need not only how many liter oil they needed, you must also have information from the customer, from the driver, how much fuel they needed for this distance. The company, they build up engines, Mercedes, MAN, Deutz, everybody, on the heavy duty system and also in the passenger cars. They say for passenger car, the maximum it's 0.1 to 0.5% of the determined of the fuel consumption. That means up to the engine how much fuel they needed, they can be more or less of the oil consumption. This is coming not from motor service or KS, this is coming from the production line or from the information from the OE companies, they build engines. This is the newest information what I have, what I receive from big companies here in Germany, 0.1 to 0.75% of oil consumption up to the fuel consumption. This is very high. But this is normal, this is okay, they say it. In the past, maybe 5-10 years ago, 5 years ago, they say maximum 0.1 to 0.5%. And they bring it a little bit higher because of the new, I will say, fuel injection system and also of the exhaust control system with DPF and so on, with all these exhaust cleaning systems behind the exhaust pipe. 0.1 to 0.75% on the truck application Here you see more than 1.5 liter per 1,000 kilometer, yeah, or more than 6 liter. This can be also, yeah, but we must have an exactly calculation. When a customer came to you and they know it, they must make a documentation how much oil they have it. Yeah? They must do a little bit more than only a documentation. They must bring you one paper and write it down. You maybe they say, okay, how many hours, yeah, they drove with this, or how many kilometers they drove with this engine, with this truck. This is now an example for a truck application. How many fuel they filled up for this amount of 720 kilometers, and how many oil they filled up, yeah, or they needed in this time or in this kind of kilometer they drove. And you see, they drove in the first line 9 hours, 720 kilometers. They need for this 720 kilometers 252 liter fuel, and they filled up after in the evening 1.2 liter oil. I make this calculation with a truck. They need round about a fuel consumption of 35 liter per 100 kilometer. This is maybe a calculation. This is okay. This is a normal truck. It's drove on the highway. When we speak from a truck application or engine days in the bus in the city, then we speak from 45 to 50 liter per 100 kilometer. After this calculation, and they say, yes, you must do it round about 100 hours or round about 10,000 kilometers, then you calculate it all together. And then you see on the bottom of this example, they drove round about 8,400 kilometers. They need 2,940 liter fuel, and they needed in this time 18.8 liter oil. Next step, when they have this calculation, this documentation, you can calculate it. Is it the oil consumption? Is it high or is it less? Here you see in the calculation 18.8 liter, yeah, of oil. Here, 18.8 liter. And then divide to the fuel consumption, 2,940 liter. And then you must multiply with 100. And then we have a calculation 0.64% up to the fuel. That means we are in the range. Everything is okay. Because what I show you before in this slide, you saw 0.1 to 0.75% of the oil consumption to the fuel, up to the fuel consumption. Is it okay? And this is, we cannot speak from oil consumption. Yes, it's very close to the end, but this can be in the first step when you overhaul an engine. The oil consumption is every time in the first time a little bit higher, and then they drops down. MAN, Mercedes, they say when we are very close on the highest position, what we can speak from oil consumption, you must drove this engine round about 50,000 kilometers. Then we can make the next calculation. And when then the oil consumption is also very high, then we can speak and see what it's happened. But I have one question to you. Is it right? Huh? And is it enough, huh, for the evaluation? Is this now oil consumption or not? Only about of this situation, what we saw it before on this documentation. I say, no, this is not enough. I need a little bit more information. I don't need the color of the truck, but I need in which situation use this customer the truck? Is it a truck? Maybe they have transport some wood sticks. Is it a tractor? They pulled with the power shaft a small cutting wood system. Is it a truck with a crane on it? Or is it a special engine? Huh? They need a lot of horsepower to cut small pieces of the wood maybe. One question to you. What do you think? Which kind of engine in this situation, A, B, C, or D, which engine have more oil consumption, or they normally can have more oil consumption? You can write it in the chat, A, B, C, or D, or in the later. Yeah, we can also discuss of this. A, you see the truck is very high loaded. B, you see this tractor have maybe more than 100 horsepower, and this machine behind them, they pulled with the power shaft on it. It's very slow. C, you see the truck with the crane. And when you use a crane on a truck like this, when they're using, they normally drove in idle speed, the engine. And D, this is a very high power machine, and they need a lot of power to cut the wood in small pieces. I will tell you which kind of engine it's using normally more oil consumption. This engine on B and this engine on C have more problem with oil consumption. And I will tell you in the next slide why. These two engines, it's drive the most of the time, or in some of the times, in idle speed. Idle speed is less power of the engine. And there's also the engine brings not the maximum load on the engine. You see it here. This is a torque curve from one engine. It's an engine. You see it on the top. This is the TTCD 7.8 from this tractor, what we saw before. And you see how many horsepower. They have 300 horsepower. Now the newest one have 300 kilowatt, 360, 390 horsepower. And you see on the bottom side, you see the torque, how many Newton meter they bring it. And you see when we speak from 0, that means you are not take out power from the engine. They runs only in idle speed. When you say we have 100% of torque, this is the maximum what the engine can build up. And I have a question. What do you think? Which working load in percent can result in a higher oil consumption? What I will ask you, when an engine it's drive and using very less load, like this line here, or they is using in the most of the time, I will take another color. It's using here. What do you think? How many working load in percent must you have that we have less of the oil consumption? I hope you understand what I mean. I will show you what it's happened. You see again the torque curve. When we have using an engine under 20-25% of load, then the oil consumption can be increased. That means when you have an engine, one example, 100 horsepower, 100 Newton meter torque, 100 hour they use this engine, and you take in this 100 hour only 20 horsepower, for this 100 hour, then we speak from 20 to 25% load. That means the engine have no stress. When the load it's climbed up over 25 to 30% of load condition. That means in the same example, 100 hour runs the engine, they have 100 horsepower, and then you take out of this engine in this 100 hour 25 to 30 horsepower, then you take or drops down the oil consumption. When you write the manual of MAN, the new generation, in the last 2 years, they changed something, and also Deutsch changed it in the manual. And they say, when you use this engine under the 25-30% of load, the oil consumption can be more than 0.7% up to the fuel. And this is very important that you understand, because it's up to the situation how the driver using the engine or the truck or this special application of construction machine. When they drive, and I will go back, the engine in idle speed, then they don't need a lot of horsepower. And then you are in this situation, like here in the picture, B and C, under 25% of load, and then they can increase the oil consumption. I will give you now in the next slide here again, when you are over 25 to 30% engine load, we have a higher pressure, combustion pressure on the top of the piston, and this pressure, it's coming down, goes behind the piston ring, and press the piston ring to the surface, to this small oil film. And then we have a better seal on the scrap end scrap function. And then we have less oil consumption. When we have under 25% of engine load, I will say much more time in idle speed, then we have lower combustion pressure, less seal and scrap function of the oil ring. That means we have one situation, and this is very important that you understand. You know it, we have a piston ring, and the piston ring have their own tension. And this tension, it's turned to the surface of the cylinder bore, the cylinder liner. This tension, it's not enough to seal the combustion area and scrap the rest of the oil to this 0.3, 0.4 micro oil film. We need another pressure, and this pressure is coming from the combustion area, goes down on the top of the piston in the fire area, and then they bring the piston ring with a higher pressure, 10 more times higher than the piston ring tension self, and press the piston ring to the surface of the bore of the cylinder liner and seal it perfectly. This is also what you can see it when you drove with a engine or with a truck, and you will go up on a hill. Up on a hill, that means you decelerated the gas pedal. We have less combustion chamber pressure. That means the tension between of the rear side of the piston ring are less. And exactly in this situation, the sealing effect is less, and then we have much more oil in the combustion area, and then we have we burn this oil, and then we have the blue smoke. The same situation with this truck. You climbed up on a hill, you pull down the gas pedal, they increase in combustion area, the pressure. The pressure between the piston ring, it's also climbing up because of the higher pressure in the combustion side. And then the sealing effect is better and you don't see blue smoke on the exhaust pipe. This is the effect of the situation, how high it's the load of the engine. Higher load, higher combustion pressure, better, or the higher pressure between the piston ring, better sealing effect. Less pressure in the combustion side, less load also, less pressure on the piston ring, and not so good sealing effect. Any question? Now you can also have time to read it down or write it down on the chat that Rob can take it for the last sort of when we are finished with the presentation. Now I will show you what can be the influence of the higher oil consumption. The influence, the biggest point is, and I think you see more of this kind of piston than myself, most of the piston, they have built up carbon on the top. Carbon, this black area on the top of the piston, and also in the ring gallery, in the ring area, there are the piston rings. This is oil they burned and built up this carbon. This carbon, it's very hard. And when the carbon is hard, they polish the cylinder bore. And when the cylinder bore is polished, they remove the scratching marks from the honing process. And we have not the best surface area to hold this small oil film on this area. And then the sealing effect can be also less, and also we have more oil consumption. This carbon built up in this situation when oil can jump up to the combustion side. But they can only jump up to the combustion side when the sealing effect is less. That means some of people think about it when they overhaul an engine. In the first time, yes, everything is ready, they put it all together, they bring the engine in the truck, they started the engine, and then they say, okay, now I must check everything is okay, no leakage, water, fuel, and everything. And behind the garage, they start the engine and they runs in idle speed. And then they runs maybe a half an hour in idle speed. And this is the first mistake what you can do it. Because in this situation, less load, you understand what I showed you before, I hope, then we bring oil to the sealing effect is less, and then also we jumped up oil to the combustion side, and this is burned, and then we build up this carbon. And when you have built up the carbon, then you have, I think I will say, produce the first failure. The best way what you can do it, and also what everybody said when I was by MAN, by Mercedes or by Deutz, they say when you overhaul an engine, look that it's everything, it's sealed, no water, no fuel drops out on the floor, and then say to the customer, use this engine what you used before. And they using normally, I will say, in the load condition, maybe between 16 to 70% or more. And then it's the best way to start to drive in an engine, I will say. This can be also an influence when you have extremely handling. You see the air filter, it's completely blocked. On this area, you see the air filter pipe, it's broken. Extremely situation, a lot of dirt around this, or also when maybe a tractor is on the field. That means a lot of dirt can come in when the filter is not okay, and this dirt, the small pieces of sand, of material, it's damage the oil rings, especially the oil scrubber ring. And also we have a big of wear on this area. There are the piston ring in the ring groove of the piston, and then the piston ring, it's not stability perfectly in the ring groove and jumped up and down, and then they cannot seal perfectly. You see also here on the right side, we have also some videos on the YouTube. You see here this, you can take your camera and then you can start a video of YouTube channel. I will show you later on the last picture of the presentation also what you can find in our homepage. This can be also a failure. This, what I will say, you must ask the customer in which situation they use this engine, this truck, this application, this tractor or this construction machine, and how good it's a service before. And when they say something of this can be not good for the engine. Some of the people, they don't think about it. Is it so important, the air filter and so on? Also, we have some calculation and have or we make the own video about how you can clean an oil filter on our website. There is also a small video. The next step, what is also influence the oil consumption, it's the cooling system of the engine. You know, the water pump in the front, the cooler, cylinder gas, the thermostat number 2, and so on. This is, I think you know it better than me because you open more engines than myself. But what I will show you, when an engine is cold, the piston is also cold. When we speak from the running condition of an engine, then we speak round about from 80 degrees of the water in the cooling system on the right side. And you see the difference how looks a piston. The piston in cold condition, it's unformed. They have not a cylinder form. They are not perfectly in the condition to run in the cylinder bore. They need first the temperature to grow up to the right diameter, and then we can have exactly in the area here around a good sealing effect. Here you see we have a lot of space on the left side, and they cannot seal perfectly on the surface of the liner. What I will say to you, when you start an engine, you must look, they climbed up as soon as possible to the normal, I will say, engine temperature, this 80 degree, what I said. The most of people, they think in the cold area, they start the engine and they start it and they run in idle speed, maybe for 20 minutes. They build up very slow the water in the cooling system. In this situation, the piston will not grow quickly up to the right diameter to make a perfect sealing condition. And exactly in this 20 minutes, when the piston is cold, in this situation, we bring up oil to the combustion site. This oil burn, build up the carbon, and then we have the same problem what I showed before. Important is to say to a customer, when you start the engine, start it. Yes, the oil pressure is there, everything is okay. The air pressure is there, the brake can open, and then start to drive the engine. Start with the load on it and then bring up as soon as possible the temperature. And then you have the best effect with less oil consumption. Don't run the engine in idle speed for a long time and wait that build up the temperature in the normal situation to 80 degrees. This is not possible. On the next slide, you have time again to write it down, and when you have any question. Another influence can be also the installation and possible failures. You have a honing machine in your workshop, I think. Maybe not the Sannen C-Key 21. This can be also other one, but I think you know it. This is also what I show you. When you hone a cylinder bore, you must look that the surface is perfectly. You have the scratching marks, you have also this angle, and you have the right roughness. You must check how high is the surface in the roughness situation. You must measure it. When it's too rough, the surface, then we have a lot of wear in the first time between the surface and also with the piston rings. When you are honed too smooth, then we maybe lose the scratching marks and also for the oil gallery, for the oil reservoir. You must be check how was before the honing area, and this you must do it again when you overhaul and drill it out and bring to an oversize and hone this. This is very, very important that you build up the same surface with the same roughness what was before in the serial, or very close to them. You know this machine, this brushing tool, and also this flex hone system on the right side. This is impossible with hone of this machine because this two brush tools or this flexible honing tool, they cannot build up a very good surface. They damage the surface of the cylinder bore. You see it in the picture. You're missing these scratching marks from the honing process, the line. They can fill up with oil, and also a lot of small pieces around of the area. They look up like a big hill, and on this it's running the piston rings, and this can't be not possible. The oil, they don't know exactly on which position they must go, and we produce with this situation, with this kind of tools, we produce definitely oil consumption. You cannot bring a very good surface with these tools. You can do another way, but this is another session of webinar, what you can do with these tools. And I know it, a lot of people, they take this brushing tool after when they finish with the honing process, and then they're using this brushing tool for a very, very short time. But this is a completely different story. Here you see we are missing this scratching area, and this is why we cannot sealing perfectly between the combustion side and to the oil pan, and the sealing effect is missing, and then we bring up oil to the combustion side and this is burned. Here you see what I said before: do not run in the engine when in idling. This is what we also wrote down in some service information, that it's impossible to do it. And this is one of the biggest points what you must say to your customer. When you go back to the slide what I showed you before, you must bring the engine in a load condition over 25%. And when they start the engine every morning and runs 20 minutes in idle speed, they drops down the load condition of them. And then they increase the oil consumption. Here it's written down what it's happened with this. And you can give this service information also to your customer and say, when you start the engine in the morning, wait that the oil pressure is there, the air pressure is there for the brakes, and then you start the engine and drive with the engine. It's the best way what you can do it. Maybe it's helpful for you when you discuss with your customer in the situation of oil consumption. I'm now very close here in the presentation. You see this is an overview of our website, and you see ms-motorservice.com. There you can find a lot of information and also videos, service information, product information. Have a look inside and take what we read down, what is helpful maybe when you discuss with your customer about oil consumption. I hope I bring you some topics to your brain to helpful for you when you discuss with oil consumption with your customer. And this is what I will say. When you have any question, you can also write me an email. But I said before, I very responsibility for a big market for training, but maybe I cannot answer as soon as possible your question. But here you can also write me information when you have a special question about oil consumption. Also, what I gave to Rob, I gave a handout, and this handout is also, I think Rob sent it out to all the participants, and then you have this presentation, or it's recorded, then you can show you again what all the topics can be influenced and what can influence the oil consumption itself. Write down the question in the chat, and now I'm in the end of the presentation, and I will hand over to Rob, and maybe some question came when I presented.
Excellent, Reiner. Very, very good presentation. And these are questions that we get on the tech line all the time at AERA as well. Is just what is the what kind of oil consumption is right and what is wrong, and so the way you broke that down, very, very good job. Great information. We have had some requests already for copies of the presentation, and if you do like a copy, like I say, Reiner mentioned he did allow us to do that. So just put your questions in there that you'd like a copy of it. We can send that to you. So yep. Reiner, there was some questions that did come in, and I'll just start listing those off for you. So the first question we have is, how do the new very light and low additive oils affect ring seal and oil consumption?
You must, I must make a small story around. When the engineer design a new engine, they say, I have a definition of surface roughness. And when we look maybe an older version of engines, the surface it's much more rougher than on the new generation. Maybe when you look on a passenger car, the 654 engine from Mercedes, they have a surface, looks like a mirror. This is very, very fine. But they have also different kind of oil. They have a viscosity of oil, a 0.30 maybe. That means up together with the surface roughness and with the viscosity of the oil, they bring the best effect of the sealing. I cannot say when you use an oil with a less or higher viscosity, the oil consumption can drop down or go up. This is also together game with how it's the driver using the engine in which load.
Okay, all right. Reiner, we've got a couple other questions here for you as well. What is the best practice for engine startup for a turbocharged engine in cold environments?
You start the engine, wait that the oil pressure increase, and then in idle speed, I will say wait 1 or 2 minutes, yeah, that you are sure every places in the engine have oil. But be careful. When you must do once before. When you build up an engine and the engine was completely clean with oil before this situation, you must make a pre-fill up oil pressure. That means you must press oil in all the position of the engine and also in the turbocharger with an external oil pump. And then you can start the engine. When you don't make this pre-filling of the oil gallery, then you need a lot of time that the oil pressure it's increase in all the situation on the engine and also on the turbocharger. Very important, look in our homepage, there is also a pre-filling, yeah, of the oil gallery. We have also make a movie of them. Take a look in our homepage, and this is very, very important. You must pre-fill first the oil gallery, and then 2 minutes in idle speed, and then you can, yeah, take the gas pedal a little bit down, yeah, and then start the engine, wait up to the temperature, and then you can start to drive. Another question?
Okay, super.
Rob?
Yeah. The question is, we've often heard of a glaze setting up on the cylinder during break-in. Can you comment on the glaze?
Can you say it again, please, Rob? What do you mean?
Sure. So what they mean is during engine break-in, there is a glaze or the rings probably aren't seating and there's a bit of a glaze on the cylinder wall during break-in. So they're wondering if you have any comments on that.
What you mean? I think this is what I prefer to explain it. When you put new piston rings, new piston, new liner, new surface, every put it together, and then in this situation you must understand all the parts they have on the top of the surface a different quality up to how they produce it. And what I mean is they must be first, I can say, married together. That the piston ring moved, they have a little bit wear on the cylinder surface, and after a while, they married perfectly together. And this married time, it's closer when you have much more pressure on the piston rings. And this is why they have also, in some cases, they have a brake behind the engine and say the running in effect will be shorter when I bring load on the engine. This is also what I said, drive the engine on the road. And then this glass, this surface, yeah, from the production, yeah, will be removed very quick. I hope this was the right answer for the question.
Okay, yeah, thanks, Reiner. Next question, does the oil volume or the amount of oil in the oil pan influence oil usage? Some engine models offer different oil pan capacities. So they just wondering if which option is preferred.
It's up in which situation they use this engine. Maybe it's a construction machine and works very often on hill, or it's a tractor. They are in the vineyard. Yeah? Maybe they climbed up and go down. They have a higher oil volume in the oil pan. Also, they have maybe special oil pans with some, I will say, plates between, that the oil cannot be jumped on the front, on the rear side when they go up or down on the mountain. When some of the engine, up to the situation they use, they have a higher volume inside or less volume. What I can say also, when maybe an engine have an oil volume, I will say 25 liter, yeah, You fill it up in the evening or in the morning, say, okay, there is missing 1 liter oil, and you fill up 1 liter oil. And then after a while, you check the oil again, and then you see, okay, I'm missing also 1 liter oil. Same fuel consumption, same kilometer they drove. But in the next morning, I fill up maybe 2 liter oil. It's only missing 1. Yeah? And then you drive again the same kilometer with the same fuel consumption, but then they need 2 liter oil. What I will say, when you overfill the engine with oil, they need also this kind of oil. Each engine needs a little bit oil, that's normal. But when you overfill and bring more oil in the oil pan, they're using more oil. This have together with the situation, you have built up a higher pressure in the crankshaft area in the oil pan, and what the piston ring remove the oil from the surface must be bring down to the oil pan. And when the pressure is higher in the oil pan, then they cannot go the oil directly and easily from the piston ring to the oil pan, what they scrapped. This is what I will say. Look that you check the oil level, and what the companies say, Mercedes-Benz or I don't know, or the Deutz, they say this is the level, fill up to this level. Yeah? And when they say this application had a higher level, this is right. They check it in the test, in the engineering department.
Okay. Yep. Super, Reiner. Here's a question, and you covered this a little bit in your webinar, but the question is, what would be the recommended workload of a recent overhauled engine, and for how long should it be run in for at that workload for the break-in?
I say it again with your words.
Yeah, I know you talked about. I know in the webinar you talked about the percentage, about like the load, how much load you should put on for break-in. But maybe if you could just let us know for how long, like how long is a typical break-in, and how long should you put that load on that engine after it's been overhauled?
The best way what you can do it, when you have a break, and you bring load on the engine, take the load round about 60% of the maximum of the horsepower. When they have 100 horsepower, then take the brake to 60 horsepower and drive it for maybe 2-3 hours. Then will be the running in effect very on the final, on the end. But you must have 60% of load of them. Best way what you can do it, when you have a engine brake, go up to 60-70%, drops down to 20-30%, and then again back to 70% roundabout. But in calculation to altogether, you must have on the brake round about 60%. Then it will be okay.
Okay,
for
and Reiner, how
3 hours.
would you? Oh, 1 to 3 hours. Okay.
Yeah.
All right. The next question we have for you is, how important is ring selection and bore finish?
How important? I will say this is one of the important point can influence the oil consumption. When the surface is incorrect, you can have a lot of oil consumption. I have one example. I was in Greece by a reconditioner, and they say we have every time when we use your piston rings, we have oil consumption. I show in the garage, and I show to the machine of the honing machine, and I saw also the tools of the honing machine. I say nothing. Then we discuss, and all what I show you in the presentation, I show to them, this customer. After them, I say, you must use the engine in higher condition. This is first. And then they say, yes, we do it, and everything is okay. And then I said, but what I saw in your garage, I saw the honing stones, and the honing stone was broken. I think the surface, what you hone on it, on the new engine bore, will be not the best. We do it very clear, everything is okay. And then I said, yes, when you say it's okay, I will come when you open an engine, and then we will see how it's a surface. Measure the surface with the roughness tool, and then will be perfect. The biggest problem, and what you can see it when the surface is incorrect in the roughness area, scratching marks and so on, you will have a lot of wear on the piston rings. And this is the most of the, I will say, question from the reconditioner, different areas. They say, yes, I overhaul the engine, I put the piston rings from you inside and so on. And then after a while, we have a lot of oil consumption. I opened the engine again, and then I check the piston rings, and I say a lot of wear have the piston rings. I change the piston rings to another piston rings, maybe from another company, and say the oil consumption is less. Yes, this is less now because they have new piston rings inside. The piston rings was removed, have wear because of the bad situation of the surface. The surface, I will say, is one of the biggest influence of the oil consumption.
Okay, so very good, Reiner. So even really important to have for shops to have like a profilometer in order to measure that surface finish is getting to be more and more important as we move forward. Yeah. Reiner, I've got one more question for you. And any of the questions that we didn't get to, if there's still some coming in or after the webinar, we'll get those over to Reiner. But Reiner, the question is, are there any oils or oil additives that should be avoided at all under any circumstances?
The oil additive can be influence the oil consumption in positive or in negative area because or due to the situation of the engine. What I will say, you cannot say one engine it's the same that the other one. You cannot say a Cummins engine it's the same engine from a Japanese engine. They are completely different because they have different stability, they have different vibration inside, and one of the engine can be possible with additive, and the other one they bring nothing. This is what you must use yourself. Yeah? I prefer personally not additive, yeah? But this is up to you, and you have, I think, find the best solution for each engine, what it's maybe a little bit helpful for the oil consumption. But please think about it, what I told you in the presentation. All this influence can be affect the oil consumption by the customer, by the driver of this engine.
Okay, thanks, Reiner. All right, well, that kind of wraps up all of the questions. Reiner, that was an excellent presentation. Very, very well done. I know it's late in your day. It's probably just past 6 o'clock where you are, so we appreciate you taking the time out of your day, especially at the end of your day, to do this presentation for us. And it was really, really good information. Again, we appreciate your time, Reiner. Thank you.
You're welcome. When you have any question again, please write it to Bob or to me.
Sure. Yeah. No. Like I say, everybody, we'll get any questions that are still coming in or that we didn't get to. I'll get those over to Reiner, and Reiner will get those answered for you. So, what I'll do now is I'm going to go over to Amanda, and we're just going to wrap things up, and we'll let everybody get on with their day.
All right. Real quick here. First off, we just want to let you know that all of our videos can be found on YouTube. Any webinars that we do upload them. It does take a few days, but you can find them all out there. Just go to YouTube and search AERA Engine Builders or Engine Builders Association, and you'll find us, and make sure to hit that subscribe button so you know every time we upload something new. And then lastly, when you do leave today, you will get a prompt to take a survey. Take a moment, fill it out, let us know how we're doing. Let us know what else you'd like to see in this coming year. And as always, thank you for attending. You can see our contact information is listed there. You can reach anyone at the AERA team by calling 815-526-7600, or feel free to reach out to Rob or myself direct. Our emails are listed there. Again, thank you everyone for taking time out of your day. We really appreciate it, and we hope you have a great rest of your week.